Good evening, my dear warrior Pandus. Good evening. Welcome to the part number 2 of Newton's laws of motion in your Roar NEET aspirant, which is RNA series, where you have daily live classes of all the three subjects, physics, chemistry, biology, and we do in depth the concept and how to apply the concept and also make you solve problems and give you the idea of how the PYQs are. So right from the basics to the proper advanced level, guys. So let's get started with your captain Shreyas. All the warrior Pandus have assembled. Hello Krishna, Alekhya, Sumi, Monest. Welcome Philo, welcome Raj, Gopal, Lan. Yes, the current electricity lecture will be conducted later on because I just wanted to make sure that this chapter was done or else you would have to wait for a very long time for the part 2. Vanakam. And yes, happy Teachers Day in advance. My class might not be there tomorrow, but maybe I'll come with a special gift for all of you on Teachers Day. So stay tuned for that. So thank you very much for all the warm wishes on the social media, and even in my DNA batch, we had a fun time today. Thank you guys, and means a lot when you give your Guru Dakshina by smashing the like button. Yes, they say that you always need to give it back. And since these classes on YouTube are absolutely free of cost, we don't ask you a single penny, just asking you to smash the like and also subscribe to the Vedantu NEET English channel. Okay, and also remember that there is scholarship entrance test which is going to be conducted very soon. You need to start registering for it now, or else you might miss on this opportunity and you might lose out on so many prizes and so many amazing questions. Also, you will know where you stand at a national level because lakhs of students give this MVSAT, which is your Mega Vedantu admission, scholarship admission test, and lots of prizes. Also, scholarships to be won on different courses. Also, free material which will be given to exclusive students, exclusively who have registered for MVSAT. Now, where do you find the registration link? Well, the link is there down in this particular description box of this particular video itself. So as you are watching this video, go down and you will find it. Register for MVSAT right over here and enter your number and start registering for it. All right, cool. So that's your MVSAT, guys. Hopefully you have already registered. Just doing a quick recap of whatever we did last lecture. We did talk about the different forces in nature, and we talked about the three laws, like when there is no force, the body maintains its state of rest. Then the second law, how when there is an unbalance, it causes the momentum to change, and we derived F is equal to ma. Then we also went to the third law, which said action and reaction. They are equal opposite on different bodies, but they don't cancel each other. We have solved a couple of problems, and then we saw different forces like weight, which is mg. Then we saw contact force, which is the resultant of normal and friction. Then we also saw about tension in a rope or a string, how it exerts the pull, acts always along the rope and away from the string element. We also seen the spring force, which is kx, and we have solved many problems which involved the free body diagram concept, where you show all the forces on the system, not within the body, only on the thing, and then you resolve the forces, write the equation and solve the problems. We have solved many questions, many questions, guys, right over here. So it's time to proceed ahead. Like I said, we'll be doing all these concepts in the next class, which is today. Okay, shall we proceed? Full of energy, smash the like button. Okay, what's the syllabus? So it depends on what you are selecting the grade as. If it is 11th, then only the first few topics will be there. If it is 12th, then the 11th standard topics will be there. If it is the dropper, then most of the syllabus will be there. Okay, but don't worry, the test is not very difficult. The test is not very easy also. So you need to be prepared. Cool. Yep. Current electricity, Manikandan, like I said, after some time. Hello Satyashri, nice to see you. Yep. Great. So let's begin. And hello Pradeep. Hello Madhumati. Nice to see you. Hello Vijay. Yep. Now let's see some questions which involve multiple pulley problems, and these multiple pulley questions are also very fantastic. Starting off with a simple concept where, see guys, if you have Imagine if you have a pulley which can move, maybe something like this. There is a thread over here, maybe it is connected across something right over here, and this is fixed and this is movable on this. So you have movable pulley, you have this movable pulley, okay, and you have multiple pulleys. So these kind of questions become very interesting. Even this particular problem, say for example, you have pulleys which are attached like this, pulleys which are attached like this to multiple blocks, and there is a block hanging here, here. These are basically multiple pulley problems, okay, movable pulley problems. You can see this pulley can move up and down. So how do we exactly tackle this? Let's have a look at it. Hello Sushmita, hi Umesh, I'm very good Sumi, and happy Teachers Day to all of you too. I'm pretty sure you're all excited for tomorrow's surprise as well. I'll be leaking it tomorrow, okay. Well, let's start with the very interesting simple problem and then we'll slowly complicate it. Okay, see, whenever you have multiple pulley and movable pulley problems, then usually multiple pulleys which are movable problems, usually there are two methods for it. Method one is you can do it by visualization, visualize it, and this visualization method involves the concept of how much string you will supply and how much string is being demanded by the other end. And the method 2 involves basically the concept of, you know, the work done by the tension is 0, which basically involves the trick where the tension happens to be inversely proportional to the motion. Tension along the motion is inversely proportional to the motion. This is the trick which we can use to solve those kind of questions. So these are the two methods. Let's have a look at both the methods in few questions so that you get a hang of it. Okay. Let's take an example, guys. Imagine I have a problem like this where there is a smooth flooring. There is a pulley over here. That pulley is attached here. There is a rope which is then attached to another pulley over here. Okay, think of it like this. There is another pulley over here and that rope is attached to that pulley, and that other end of the rope is attached to another mass, maybe a mass of m. Now this pulley has a rope wrapped around it. That rope is attached to the wall on one side, and you will see that there is a mass which is being attached over here. Maybe I can call that particular mass 4m or 3m, whatever you want. Okay, some random mass over here. Now when the system is released, this mass will come down, this pulley will be pulled, this 4m will also move. So how the motion will be, what are the accelerations, that's what I'm interested in. Let's try to do this. Okay, let's try to do this problem. So I'll try to visualize this, guys. So observe this very, very carefully. Observe this very, very carefully now. Okay, what I will do, okay, the pulley was here initially. That particular block was here. Another block is over here. Rest of them are just strings. Rest of them are just strings right over here. Okay, now just slowly start moving one block step by step and see the effects or the repercussions on the other things. For example, imagine my box over here comes down by some amount. Say for example, it comes down by some amount over here like this. So it has moved downwards by some amount of x. So there is a sudden demand of the string from this pulley that, hey, listen, I have come down. This point needs to come down over here. So you give me x amount of string. So x amount of string should pass over the pulley. If x amount of string should pass over the pulley, so where will it come from? It has to come from this pulley's this point. So this point will have to move ahead. How much will this point move ahead by? Think about it. Obviously, that also has to move by the same amount. Yep. Hello, intellectual booster. Yes. So it also will have to move by the same amount, guys. So that's why you will see this pulley will probably be somewhere over here after some time. And how much has it moved? That pulley also has moved by an amount of x. But the moment this particular point, this center which was here, has shifted by some amount right over here. I hope you can see that. The moment the center shifts over here from here, there is a need of the string here as well as here. Just think about it. The pulley was here, now it has moved here. Earlier the string was wrapped like this, now the string has to be wrapped like this. Are you able to visualize it? Earlier the string was wrapped like this. Because the pulley goes here, now the string has to be wrapped like this. That means string is needed here and here. So you need the string. There is a demand for the string. How much demand will be there? How much demand will be there, guys? There is x amount which is needed here and x amount which is needed here. So how much amount is needed? Basically a demand of, there is a demand of how much? 2x string over this pulley. Where will the demand be met? Where will it be supplied from? Can this guy supply it? No, right? So that's why this block will now have to move little bit ahead. It will have to move little bit ahead, guys. It will have to move little bit ahead. Yep. It will have to move somewhere over here like this. And how much amount will it move now? The amount by which it will move, the amount by which it will move ahead, it will be obviously the double of x, which is 2x. X over here, x over here. So both these x's get distributed in both of them. So if this block comes down by 1 centimeter, this pulley moves by 1 centimeter, you need 1 centimeter here. So this block will move by 2 centimeters. This is the visualization technique. Are you clear about it? Understood? Everyone till this particular point? Let me know. If you are understood till this point, then you will also appreciate the fact that if this body has a velocity, if this body has some velocity of v meters per second, naturally the pulley will also move by v meters per second, but this block over here will move double the speed, so it will have a velocity of 2v. Same way, if this box has an acceleration of a, even this pulley will have an acceleration of a, but this box over here will have an acceleration of 2 times of a. So now we have found out the relationship between the velocities or accelerations. So that can help us solve the problem further. So the point is, guys, move one thing and see what is the effect or repercussions on the other, and accordingly solve the problem. That's method 1. Usually it is time consuming. But let me tell you, there is a much simpler way of doing the same question. What you do is just show the tensions in each of the strings. Say for example, on this 4m mass, it will be pulled by some tension over here. That same tension will continue in this string. So if there is tension T here, there is tension T here, this string will have a tension of 2T. T and T will add together 2T on this pulley. The same string continues here. So on this mass, the tension will be 2T. Just show the tensions. Now, where will mass m and 4m move? M will move either up or down, let's say. So this is the direction in which they move. 4m will move basically along this direction. Already you can see the tension is in the same direction. Already you can see this tension is also in the direction of the motion. That was the method, guys. If you notice, I mentioned tension along the motion. So yes, tension is along the motion, just check that. If the tension was somewhere here, what to do, we'll see it in another problem. But for now, the tension is along the motion. If you notice, the tension over here is T, here it is 2T. It is inversely related to the motion, which means if this is T, this is 2T, then this will be 2x and this will be x. So the amount by which this moves is x and the amount by which this moves is 2x. So naturally, the acceleration of this guy will be a, so this acceleration will be 2a. So directly we can tell this. Directly we can tell this by just looking at the tensions. This is a very simple trick to solve the problems. It saves you a lot of time. Okay, I hope this is clear. Fine, Jay, I will definitely consider it. Yep. Now, after this, you can solve the problem. After this, basically, it is just solving the problem, guys. So, once you know that, okay, this guy's acceleration is a, this guy's acceleration is 2a, it's just about solving the problem. So, this is a, for example, this 4m is basically 2a. Now, you draw the forces on each one of them. On this guy, it is 2t, because here it is t. Then there is mg over here. And lastly, there will be 4 mg downwards. And of course, normal force upwards. Nothing else is there. So you can start by writing equations. Like for example, for the 4m mass, there is only one force. The mass is 4m into acceleration is basically 2a. So it is basically 8 times ma. So tension is 8 times ma. For this particular mass, I have written down Newton's law. Now write the equation for this guy. Acceleration is down, so mg is also positive. So mg minus because tension is opposite to acceleration. So 2t is equal to m into a. But wait a minute, I already know the value of tension. It is nothing but 8 times of ma. So is equal to ma. So that is mg over here. So therefore, mg will be, take this on the other side, will be ma plus 8 to the 16. So 16 times of ma. Everybody with me? Yes, perfect. So this will make it 17 times of ma. And that would be mg, but out of that m and m will cancel. So basically acceleration will be g by 17. Acceleration will be g by 17. So from this I get my final answer, guys. The acceleration of mass m is a. So a was g by 17. Acceleration of the mass 4m was 2 times of that. So it will be 2g divided by 17. That's it. That is the answer. Understood how to solve this kind of question? Find the relationship between the velocities or acceleration, draw the free body diagram, write Newton's law equation, solve them until you find the desired values. Perfect. Let's take another question, guys, so that you guys get a perfect hang of it. Let's take another question. Okay. So let's say we have block over here. Okay, then we have one pulley over here, then one pulley over here, pulley over here, maybe you can just put it like this. Okay. Here, okay, and then one more pulley over here. It's crazy amount of pulleys, and then you have one more block over here, like this. Let's say this is m. Let's say this is 2m, and the string goes like this. Like that. Okay, it's not that great, but I think you get the idea. This is attached on the roof like this. Question is to find the relationship between the acceleration, rest Newton's law is applying, you know that. Let's try to solve this particular question. Doing it by visualization will be scary enough. Do you guys agree with it? Doing this problem with visualization will be quite tedious, unnecessary, lengthy. and confusing. Rather, let's do it by tension method. Because if I had to do it by visualization method, then I'll have to think, okay, 2m mass might come down by some amount. Okay, so then this pulley will also come over here. Okay, I will need some string here, here, even this string will come down over here. So I need that string. Where will it come from? It will come from here. So this mass will go up. Looks very confusing. Let's avoid all that confusion. Let's just take, say for example, there is only one string which is going around here. So on this particular part, if I take the tension as T, so from this side the tension will be T, from this side also the tension will be T, and the same string continues. So on this it will be again T. So if you look at it carefully, you will realize that our 2m mass versus the m mass, both of them move like this, up or down. Whether it moves up or down does not matter, but this is the line of motion. On m mass, the tension is T. On 2m mass, the tension is not T, but T plus T plus T, which is actually 3T. Do you see that? All these three tensions together are indirectly applied on the 2m mass. So now, if you see the ratio of the tension is 3T is to T, therefore the ratio of the acceleration will be 3A and there will be A over here, inversely related. If this was 5T and T, this will be A and this will be 5A. That's what the trick is. So very simple guys, if this guy goes down with A, this guy will go up with 3A. Is this now very, very simple? Such an easy trick to solve the questions. You take even inclined questions, even then you can solve this. Say for example, you have a question like this. Say for example, you have a question like this where there is a block of certain mass over here and it is connected over this particular pulley which is over here, and this mass goes and connects another mass which is free to slide on this horizontal surface. Maybe this is 2m and maybe this is angle theta. Even for this you can solve it. How? First, look at the string. There is only one string connecting, so there is only one single tension. So if the tension on this guy is basically T, then on this guy also the tension is T. But how about the motion? This 2m will move either right side or left side, say. So this mass will also move either left or right. If somebody pulls it, that 2m will come here. If somebody pulls this, then this mass will just go over here. At this instant, the angle is theta. Yes, the angle can change, but at this moment, the angle is theta. So what we can do now, see the tension, whether it is along the motion. Here it is, but here it is not. So the tension along the motion is actually T cos theta. So the actual tension you should consider is T cos theta and T, which is along the motion. So acceleration wise guys, so you will see that if this is nothing but A, this will be A cos theta. So if this is 2 meters per second square, this will be 2 cos theta meters per second square. That is the relationship between the accelerations. Is that clear? Thank you Sukanya so much, means a lot. Thank you for the wishes. Okay, very, very straightforward. So these kind of questions you will be able to solve guys. Even say for example, let's make it even more complex. Let's make it even more complex. Let's say you have a mass like this, which is free to slide on this particular rod, and there is a thread which goes over a pulley wrapped around it, and then it goes and connects another mass right over here, and this mass is lying on a smooth floor. Somebody pulls that thing, so maybe the motion is along this direction. So when you pull this, the string gets pulled. When the string gets pulled, this gets pulled. So this mass is only allowed to move up and down on this rod. So what is the relationship between their motion? If I call this as M1 and I call this as M2, what is the relationship between their motions? So assume that the angles are also given to me. Let's say this particular angle is theta, and let's say this particular angle is, let's say, phi. All these angles are also given to me. I know this is the direction of the motion for mass number 1. Mass number like this, mass number 2 moves in this particular direction. Okay, up and down like this. Okay. Tension, there is only one string, so single tension, one tension here and a single tension here. But take the component of the tension along the motion. So this is the component which is T cos phi, and this is that component which is T sin theta, guys. T sin theta. That's it. Now, if you assume that this guy's acceleration is, let's say, a1 and this guy's acceleration is a2, basically a1 by a2, remember, motion will be inversely related to the tension along the motion. This will be equal to, see this, for a1, what is the tension? T cos phi. So for a1, the tension is T cos phi. Cos phi will come below. T cos phi will come below because it is inversely related. For acceleration 2, what is the tension along the motion? It is T sin theta. So it will be inversely related. So if this is denominator, this will be in the numerator. So that's why a1 by a2 will be sin theta by, sorry, why did I put sin theta? My bad, guys. Sorry. So sorry, guys. This was cos theta. So sorry. This was T cos theta. My bad. This is cos component only. My bad. So this will be T cos theta. Yep. So this answer would be just cos theta divided by cos phi. So that will be the value of the ratio of the accelerations. Is that right? Understood? Check this out. Clear, guys? Yes, Krishna, cos. Yes, like this numerical problems can also come. Yes, Sanju. Thank you so much. Thank you so much, means a lot. Yep. So this is something that you should know, where rarely questions come, but if it comes, you will be in a position to solve it. See, many students while preparing for NEET exam, what they think is, will this question come or not? They check the frequency. Sir, in last 10 years, this question was asked only once, sir. Then in next chapter, you find one more question, sir. This type of model question was asked once in last 5 years. Sir, very rare. Sir, this question was asked only once in last 15 years. So then what happens? You start neglecting these questions. And what happens is exactly what you skipped comes in the exam. And then you're like, shit, I should not have skipped this. This also came, this also came. So you don't know what your luck is going to be. Plus, you know the rank inflation is high. For all you know, NTA might actually choose those non-conventional questions to bring down the ranks. You don't know. Not trying to scare you, but telling you the truth. You don't know. So better to be prepared for every kind of question, no matter what the question is, you should be able to solve. When you are so confident, then tell me, will you be scared of the exam? Obviously not. You will be like, okay, bring it on. Just get the question, I'll be able to solve it. It's not like you'll be praying before the exam, I hope this type of question only comes. This type of question will not come. This mentality comes when you watch videos like which chapters to skip, do these 20 chapters or do these 20 topics for getting 120 marks. If you watch these videos, that's when the mentality develops. And you do not get those 120 marks by doing those chapters. In fact, you get much less because you will not do those topics also thoroughly. And what guarantee that will repeat this year? Okay, so that's okay for the last moment, but when you have enough time, do not even think about skipping anything. So those are the kind of multiple pulley questions that you should be aware of, right? Now, after this, we'll go on to the topic of basically this pseudo force, and then we'll go to friction. See, imagine, okay, there is a pandu over here, and this pandu is probably moving with a constant speed of, let's say, 5 meters per second. He sees that, okay, listen, there is a box which is kept on the floor. Maybe the mass of the box is, example, 2 kg. It is just kept on the floor. And he will see that the box will have no acceleration at all. Okay. As for the pandu observer, if I'm moving with a constant speed, the box will move with a constant speed backwards. So I will not see the box accelerating. Why? Because relative velocity will be basically constant. When velocity is constant, acceleration is 0. Now what happens next? Thank you Harishine, means a lot. Hello Abdul, welcome to the channel. All right, thank you Tanuja, thank you guys for coming to the channel finally. Yep, and mark your attendance quickly. Moving on to the second part of NLM. Thank you guys. Now what this guy will say is that, okay, there are two kinds of forces acting on this block. One is this 2G force and the second one is basically the normal force. That's it, nothing else is there. So in the y direction, I will say normal minus 2G is equal to 0. That's what I will say. There is no other acceleration, no other force. And in the x direction, there is no force at all. This was in the y direction. In the x direction, the force is 0, the acceleration is 0. So yes, I can say fairly that Newton's laws of motion are nothing but valid, and I am very happy about it. Now what happens? That same box is being seen by somebody else. Who is that somebody else? Our Champa. So Champa over here, okay, she is basically running and picking up speed. In fact, she ends up accelerating. Maybe her acceleration is 4 meters per second square. 4 meters per second square. So when Champa sees that block, what will Champa see? Champa will see, oh, you know what? That block is actually accelerating backwards for her with a speed of, acceleration of 4 meters per second square. Make sense? If you move towards something, that something will move towards you with the same motion but opposite. That's the concept of relative motion, right? Now what happens is, if this Champa draws the free body diagram, she will say, okay, there is 2G downwards, there is normal upwards. So in the y direction, she will say normal minus 2G. There is no acceleration in the y direction, that is 0. But in the x direction, she will think, how come this box is accelerating? There is mass of the box, which is 2. There is acceleration. There is acceleration also, which is basically 4. But then the problem is, where is the force? The problem is, where is the force? There is no force. Which means what? Newton's law of motion are no longer valid. They are no longer valid just because this Champa ended up accelerating. Because this Champa was accelerating, so that's why she is not able to apply Newton's laws. This seems pretty unfair on Champa, that Pandu is privileged to apply Newton's laws, but Champa does not have that opportunity to apply Newton's laws. In fact, even if she applies, it seems to be invalid because there is no force which can accelerate it with 4 meters per second square. Now, what is the difference between these two observations? One, this Pandu who is moving with no acceleration, such an observer is called as an inertial observer. What is he called? Inertial observer or inertial frame of reference. Maintaining the inertia, maintaining the speed. So that guy is called as an inertial observer. Welcome JEE Preparation on the NEET channel. Wow, we have all mix and match, and we have NEET students also on the JEE channel. What is this observer like Champa called? She is not maintaining the speed, she is increasing or decreasing, she is accelerating. Such an observer is called as a non-inertial observer. Non-inertial observer. Is that clear, everyone? The difference between an inertial and a non-inertial observer. Imagine I am driving a car and I am maintaining a speed of 60 kilometers per hour. Will I be an inertial observer if I look outside the window? Yes, I am maintaining the speed, maintaining the direction, no acceleration. I am applying the brakes. When I am applying the brakes, will I be inertial or non-inertial? Well, I am applying the brakes, I will have retardation, that means acceleration is there. So I will become like the non-inertial observer. I am inside a lift, the lift is at rest, nothing doing. I am an inertial observer. The lift begins to accelerate upwards, I will become non-inertial. Once it accelerates, then it maintains the speed. Constant speed it goes up. Again it will become inertial observer. The lift brakes, stops on maybe 10th floor or 20th floor. While braking, again that lift will become non-inertial observer. So whenever the observer or the frame of point of view is accelerated, that becomes non-inertial and you will not be able to apply Newton's laws. But obviously, we are not very happy about it. We want the Newton's laws to be valid because come on, how can you make Newton unhappy? So, have you heard about those incidents in your school where the teacher's pet, by mistake, the student was sick. The teacher's pet was sick. So, not studied for the test, got 30 marks instead of 35 marks. Teacher only will feel sad. How can I give fail to my pet student? So, what will the teacher say? You come meet me after the class, get your paper. 30 marks, you want 5 marks, grace marks. Okay, 1 mark here, 2 marks here, more 2-3 marks here. Okay, plus 5 marks. You are pass. Happens? Have you seen it happen, or it happened with you only? Maybe you only were teacher's pet. Hi, Mardai. Yep. So, you get grace marks, right? Have you actually passed? No. But by force, you are passing. Just hypothetically, you have passed for formality's sake. So, same way, who is the pet of everyone? Newton. Can you make him fail? No. So, what will you do? You will pass him. How will you pass him? As follows. You say, okay, I am not going to say Newton's laws is invalid. I don't like it. I don't like it. Oops, what is this? In fact, I will say, no worries. Let me create a new force only for you, which does not exist, but I will create it for you. It's a fake force. A fake force is also called as a pseudo force. And I will say that pseudo force is responsible for the acceleration. Like, oh, pseudo force is there. Oh, so that pseudo force is causing that acceleration. So, in a non-inertial frame, to make Newton's laws valid, so now Newton's laws of motion are forcefully made valid by using a concept called as pseudo force. The value of the pseudo force, you can see, is the mass of the body into the acceleration of the observer, but it is in the opposite direction. Yep. So, what is this pseudo force? It's not a real force. It's just used to make sure Newton's laws can be applied on paper. It is just on paper, guys. Remember, nobody actually applies it. Don't call that, sir, that force came from the universe. Sir, I meditated and I saw, sir, light was coming and that force came from the center of universe. No, it didn't come from anywhere. It's not an actual force. It's a fake, not a real force. Keep that in mind. So, I can say that whenever I have something like a non-inertial frame of reference, such a non-inertial frame of reference might have some acceleration. Let's say that acceleration is A. This is the acceleration of that particular frame. This is the acceleration of that frame. This is that observer. This observer might see anything, any object, let's say this particular mass. On this particular mass, there might be forces like tension, normal, spring, whatever, gravity, etc. So, different forces might be there. And apart from this, you need to apply an extra force, and that is the pseudo force. Pseudo force always acts opposite to the acceleration of the frame. So, you will show that force acting like this, and this is that pseudo force. Apart from this, you might have some acceleration of this mass. This mass might be moving somewhere. So, maybe there is some acceleration small a like this. Please remember, this small a is nothing but the acceleration of that particular body, for that acceleration of the body with respect to whom? With respect to the non-inertial frame of reference. This acceleration is the complete acceleration of the frame. This is acceleration of the frame itself from the ground, maybe with respect to the ground. So now when you apply Newton's law, this is how you will apply. Usually you would have said all the forces added together will give me nothing but the mass times the acceleration. Mass times the acceleration. Now you will not say this. There is one thing extra that you need to add, and what is that one thing? You will say plus the pseudo force. Plus the pseudo force. What is the value of the pseudo force? The value of the pseudo force is the mass of the body, into the acceleration of the frame, but with a negative sign because it is opposite. But magnitude wise it is just ma, direction wise it is opposite. So these are the things that you should definitely remember. Okay, everyone with me? This is the modified Newton's law. Clear, guys? Everyone? Let's solve a question now. Let's solve a question so that you guys get an idea about this. Let's solve a question. Okay. Let's say there is a train. Let's say there is a train like this, or a bus or whatever, and this particular bus is basically being accelerated at, let's say, 4 meters per second square. 4 meters per second square. This flooring is smooth and there is a box on it. Somebody is trying to, somebody is trying to push it with some force, and that force is also given to you. And that force is, let's say, 10 Newton. 10 Newton of force is being applied. The mass of this particular body is, let's say, 5 kg. Is basically 5 kg. Now, imagine there is an observer. Inside this particular bus or this train. That person is moving along with the bus. What will this person see this box doing? What will this person inside the bus or the train see the box doing? Okay. So the question is the motion of the box with respect to the observer inside. With respect to the observer inside. That is the question. Tell me one thing. Is the observer inertial or non-inertial? Quickly in the chat box. See what is the observer doing. He is inside the bus. The bus is moving with the acceleration. So if the bus or the frame is accelerated, he is 100% a non-inertial observer. Okay. So one thing for sure, guys. I'll just put it over here. So this observer is non-inertial. One thing I know, the moment anything is non-inertial, I should definitely apply this concept of pseudo force. So let us see what are the different forces acting on the body. First is its own weight, which is nothing but 5g. Then there is normal force over here. Then there is normal reaction over here. But at the same time, you have also applied that external force of 10 Newton, and there will be one more force, and that is pseudo force. Where will that pseudo force act? It will act exactly opposite to the acceleration of the frame. The frame was accelerated this way. So that frame had an acceleration of 4 meters per second square like this. So there will be a pseudo force exactly in the opposite direction, and that would be the mass of the body into acceleration of the frame. For now, I'll just put Fp, whose magnitude will be mass of the body, which is 5 kg, into acceleration of the frame, which is basically 4. So 5 into 4 will be basically 20 Newton backwards. 20 Newton backwards. And as a result of all these forces, obviously the block is not going up or down. The pseudo force is behind. This 10 Newton force is ahead. So I think the resultant force will be leftwards. So I think it will accelerate this way. How do I know? Because this 20 is more than this 10. So this is less, this is more. So it should go towards the left side. So this box will go and hit this person over here for sure. Wow, interesting. So now let's apply Newton's law and see what do we get. There is only one force in the x direction towards the right side, which is 10. Apart from that, the pseudo force acts towards the left. So I think we should take the left side direction as positive because acceleration is also left side. So 20 Newton minus 10 Newton is equal to our mass into acceleration. What is the mass? It is 5 kg. What is the acceleration? Well, that's what I need to find out. 20 minus 10 is basically 10. So therefore, the acceleration will be 2 meters per second square. So I will say that the person inside sees the box sliding towards him with a relative acceleration of 2 meters per second square. That's what the person will see doing. Is that clear? Is this example giving you a clear-cut idea of how pseudo force has to be additionally considered apart from other forces while writing your Newton's law equation? That's all. That's the main thing, main outcome of this discussion. Let's take some more problems so that you get a perfect hang of this pseudo force concept. So again, let's take a frame, and let's say that particular frame is being accelerated by some value of a. There is a pendulum. That pendulum, which was originally like this, it will swing over here and it will become stable. It will make certain angle. It will make certain angle with the vertical. It will make certain angle with the vertical. The question is find that particular angle. The question is exactly to find that particular angle. So let's try to do this question. I feel it's better to sit inside and make all the observations. So let's choose a person who is sitting inside. So obviously that person will be non-inertial observer because that observer is accelerating like this. Now, if you see that pendulum whose string is like this and show all the forces on the pendulum, let's see what are those forces are. One, the weight will be there down. The tension will pull the mass like this. And notice now, if you see, I draw a vertical like this. Think about it. What will this angle be? What will that angle be? Just think about it. If this was theta, obviously this will be theta because these are a pair of parallel lines. So hence, this will be also theta. If this is theta, obviously this is also going to be theta, alternate angles, parallel lines, correct? Okay. Apart from this, I need to also show the pseudo force. Pseudo force always acts opposite to the observer's acceleration. So hence it will be here. The value magnitude is mass times the frame's acceleration. Okay. And as a result of all of this, what is this observer seeing this mass doing? If you are inside that train or that container, you will see the pendulum has come back and it is just staying there as you move with it. As you move along with it, the pendulum is always making a fixed angle. The pendulum is not moving for you. Maybe for an observer outside it is, but not for you. So 100% this particular thing is going to be at rest. And when things are at rest, it's a problem of equilibrium. All the forces add up to be zero. So better to take components of the tension, guys. So take one component of tension over here and take the other component of tension over here. This will be T cos theta. This would be T sin theta. So if you notice in the horizontal direction, tension's sin theta component is balanced by the pseudo force. And the pseudo force is mass into acceleration. That is what I saw. In the y direction, the tension's cos component is being balanced by mg. Tension's cos is balanced by mg. Next step is obvious, I need to get rid of tension. So divide x with y. Divide x with y, t cancels. I'll be left with sine theta by cos theta. Cancels, which is a by g. So rearrange it, this will become tan theta. So a will become nothing but g tan theta, or rather I just wanted theta, I believe. So tan theta is nothing but a divided by g. So I found out the value of theta. Theta is tan inverse of a by g. Theta is tan inverse of a by g. Understood, my dear students? Very, very straightforward kind of question. Beautiful question. Okay, so that's how you solve the questions of pseudo force. Let's take more questions involving some lift problems. Let's take some considerations over here. Imagine there is a box of certain mass kept over here. There is a box of certain mass kept over here. And in this case, the lift is going up with some acceleration. Here the lift is coming down with some acceleration. Then same things continue over here. This mass is there. The acceleration is 0. Okay. And let's take another case where it is doing something like free fall motion. It is doing something like free fall motion. Okay. Now in all these scenarios, I want to figure out what might be the normal force acting on this mass kept inside the lift. The normal force, how much reaction it is experiencing. That reaction gives me an idea of how much weight is probably being experienced by that mass. Because think, if you are pushed down a lot, your legs will get pressed against the floor, the normal force will increase, you will feel you are become heavy. If you go to another planet, what happens? Your weight increases, on the ground you apply more force, the ground also applies more force, you get a sensation that you have become heavy. But if you go to the moon, maybe you will not be pulled down so much, so the normal reaction also won't grow so much and you might feel a little bit lighter. So that sensation of being more heavy or less heavy comes because of, the reaction forces which you are experiencing from the ground. Okay, so let's take the simple case first where you are not even accelerating. So when your acceleration is 0, what kind of observer will you say this is? Obviously, you are now an inertial observer. So there is no need of pseudo force. The different forces will be something like this. There is going to be one mg over here and there is going to be one normal over here. And if you are even an observer inside this particular lift, if you are an observer inside this lift, you will see this mass is going to be at rest. So you will just simply say, sir, normal minus mg is mass multiplied by acceleration. Sir, the normal force is equal to mg. That means you will get the true weight experience. If the lift is at rest or the lift is not having any increase or decrease in the velocity, you will obviously experience your own true weight while standing. You will not feel, oh, I have become suddenly heavy. Oh my God, is it something like I'm losing contact with the surface? Am I becoming lighter? That sensation will not come. Is that obvious? Is that understood? Okay. All right, Haran, I will definitely consider it. Now, let's take these two cases as well. Our usual suspects are there. Usual suspects means usual forces, like mg is there, normal obviously will be there. Then you also will get this mg over here, and you will also again get another normal over here. And now our observer inside of this, our observer who is there inside of this is definitely going to be a non-inertial observer. Both of them are non-inertial observers. So obviously they will apply an additional force which is pseudo. If the lift is going up, pseudo force will be down. So our pseudo force will be like this. The magnitude will be mass of the body into the acceleration of the frame. Here lift is going down, so the pseudo force will be up, and again the magnitude will be mass of the body into the frame's acceleration. As a result of all of this, what are you seeing this particular mass doing? This mass is still going to be at rest. This mass is still going to be at rest, so that means there is no relative motion between the observer and that box which is kept on the lift. Correct? So let's write the equations now and see what do we get. I think there will be a small change. Upward force is normal. So normal minus mg minus ma is equal to 0. So therefore normal will be, take both of them on the other side, m into g plus a. Whereas over here I can say ma plus normal is equal to mg. So therefore normal will be, take ma on the other side, so it will become m into g minus a. Here it is g plus a, there it is g minus a. Compare it with this one. Normal usually should be mg, but now you are getting mg plus a or mg minus a. What does this tell you? It tells you your weight experience will be more here, your weight experience will be less over here. So this is more than the true weight, more than our true weight, and here it is basically less than our true weight, less than our true weight. It kind of makes sense. When the lift suddenly goes up, you feel as if the blood has gone from your head to the foot. You feel suddenly pressurized because the lift is trying to push you up. You maintain your inertia. You feel pressurized. You feel your weight for that instant has increased. Apparently, that is a notion. But if the lift falls suddenly or drops suddenly, you lose contact partially from the surface and you feel a little bit lighter, and that is why the apparent notion is that your gravity has become less. You feel like that. Actually nothing has happened. It's just that the sensation that you get. So my dear warriors, whenever you have lift problems, basically usually what it involves is nothing but the gravity inside the lift perceived is only very different. If the lift is not accelerating, then you will perceive only the true gravity. You will feel that there is true weight. But if the lift is going up or down, acceleration is there, then you will feel either the gravity has become more, like g plus a, or you will feel that it is g minus a. And in a very special case, when you are doing free fall, then what happens is, if you draw the free body diagram, mg will be here. The pseudo force obviously will be like this, having a value of m into a. Free fall means the acceleration is exactly equal to g. That means pseudo force will be m into g. Do you see mg and mg are cancelling? So there is no room only for normal force. So that normal force, guys, even if you put normal plus the pseudo force minus mg is equal to 0. So the normal force will be mg minus fp, but our fp itself is mg. So the normal force is just a big fat 0. So you will experience a feeling of weightlessness. It's just like somebody cut the rope of that lift. So what will happen? The lift will fall freely. Everything will start floating. And you will be like, oh my god, everything is floating. Sir, this is like gravity is only gone. Somebody turned off the switch on the gravity. But actually what has happened? You're falling freely. Pseudo force is balancing the weight. You do not experience any ground reaction or the floor reaction. Everything will appear to be as if floating. There is no perceived gravity at all. Is this concept clear, my dear students? So this is the concept of perceived gravity in all these cases. So just to summarize this, you get this concept called as apparent gravity, apparent or something what you perceived, or effective gravity. this will be, depending on different cases, it will be exactly equal to G when your lift is basically at rest or moving with constant speed, moving with constant velocity. That means acceleration is 0. But if you are going up with an acceleration of a, then it will be G plus a. If you are going down with an acceleration of a, then the perceived motion is G minus a. And if you are going with a free fall kind of a motion, then the perceived gravity is a big fat 0. You feel complete weightlessness in this case. This is very useful for solving problems. Okay. Parigla Rahul, can you please ask that in English? Okay. Sometimes I don't understand complex words. Okay. So this is the concept of apparent, perceived or effective gravity. How you can use for solving some more questions is, imagine somebody tells you, you know what, there was a person inside, and this particular person has thrown a ball. That ball goes and touches just the ceiling of it and falls down. It just touches the ceiling. Can you find the condition for it? Then you will be like, yes, why not? Assume the speed of the ball to be u, assume this angle to be theta. So then this particular height will become the maximum height of the projectile, guys. This will become the maximum height of the projectile. Are you able to see why this is the maximum height of a projectile motion? And what's the formula for height of a projectile motion? U square sine square theta divided by 2g. U square sine square theta divided by 2g. Now this would be okay if the lift was at rest, but just imagine the lift to be either going up or going down with some acceleration. Either it is going up or let's say it is going down with some acceleration. I think this g value has to be changed in either of the cases. If it was going down, then I'll put g minus, and if it was going up, then I'll put g plus, and then I can put this value of a. That's it. So I will just change the sign and I will add or subtract depending on whether it was going up or down. And then this becomes the condition. So for lift problems, just solve as if the lift is not there. Normally, just forget that the lift is there. Solve the problem normally, and wherever you see g in the end, replace it with g plus a or g minus a in the end. Did you understand it? Everyone, just let me know quickly. Yes, Madhumati, clear? Hi sir, physics NCERT Chadwala notes to part 2. For physics NCERT, I'm not really sure, Parigla. What do you mean by that? Can you please elaborate? Okay. So this was the concept of pseudo force and multiple pulleys. Are you ready to start with friction and block problems, guys? Let's start with friction and block problems. Ready for it? Great. Let's talk about friction. Whenever two surfaces rub, you encounter some resistance. That resistance of motion is called friction. So friction is nothing but the resistance to motion or its tendency. It's a evil force, but at the same time it is also a helpful force. For example, when you want to apply brakes, then the friction force between the brake pads and the wheel is going to cause that retardation. If friction was not there in nature, then you will never be able to brake. No matter how you try, hard you try, all surfaces would be smooth, you will never be able to brake. It's not a good thing. You will go and bang into something. You will not be able to walk on the floor if there was no friction, because friction helps you in holding or getting a grip on the ground. Remember, you buy slippers or shoes with good grip. If you have seen those slippers which worn out, then you might have fallen down while walking. Why does that happen? Because there is no grip, or you move on a wet slippery surface, you fall down. So friction is also good at times. Also, friction opposes the motion. So if you are trying to push, let's say, a heavy table, you have to first apply a large force so that you can overcome the friction and start moving that heavy furniture or that box. So it is making your life difficult in some cases. Also, it is making your life good in some cases. And like I have explained before, if there are two surfaces, no two surfaces will be perfectly even. You cannot make it perfectly polished so that, they become perfectly flat. At macroscopic level, there are peaks and valleys. That peaks and valleys which are there between two surfaces is what exactly causes friction. So now what happens is, if you see, this is the upper body, this is the lower surface. The upper body might encounter a total contact force. This is your contact force altogether. A component of the contact force which is perpendicular to the surface, that is basically called as the normal force. The component which is parallel to the surface, that is what is called as the frictional force. That is what is called as the frictional force. That's it. This particular angle that you see over here, I can call it lambda. That lambda is called as the angle of friction. That is called as the angle of friction. It also says if lambda is less, this component will be less. If lambda is 0, there is no friction. If lambda is more, then this component will become more. So it tells you about, qualitatively how large or small the friction is. So to write the equations over here, guys, very simple. Contact force is nothing but root of nothing but the normal square plus the f square. Also, you can say over here tan of lambda, this if you take it here, opposite side will be the frictional side, adjacent side will be normal. If you construct a triangle, this will be equal to this. So that opposite side will be just friction, guys. So it will be friction divided by normal. So these are some basic formulas which you should know before starting friction. Cool, everyone? How did I get this? Pythagoras theorem. Okay, this is hypotenuse, this is adjacent and opposite side. So sides square is going to be the hypotenuse square. Perfect. Cool. Now, if you understood till here, let's actually see there are different manners in which the friction behaves depending on what is exactly happening. So we have two different types of friction, guys. One is basically, let me put it over here. One is basically called as your static friction. The other one is called as your kinetic friction. Symbolically speaking, static friction has a symbol small f with a subscript of s. This has symbol of small f with a subscript of k. Just like the name suggests, they exactly mean that only. Static means when the object is at rest. Kinetic means when the object is in motion. So the values, the magnitudes, the directions, the behavior, everything might depend on what is happening, whether it is at rest or whether it is moving. Accordingly, the frictional forces have different values and different formulas. So we'll see that. Starting off with the basic definitions, I'll just write the difference table so that you get an understanding, and then I'll show you what it is. So static friction acts, this basically acts when there is no relative motion. When there is no relative motion between the surfaces. this particular force acts when there is relative motion, between the surfaces. Let me just create a duplicate of this. Yep. Next important point, this force always opposes the tendency of motion. It always opposes the tendency of motion. This always opposes the relative motion. Next, kinetic friction is a constant force as long as it moves, but static friction is a self-adjusting force, There is a limit till which the static friction can increase. There is a limit of static friction, which is also called as Fs max. Here, there is no such limit, since it is just a constant force. The value of the kinetic friction is going to be mu k multiplied by n. The value of the static friction can be anywhere between 0 and the maximum limit, which is basically Fs max. And this value of Fs max is given by mu s into n. This is a range of values because it is self-adjusting, and this Fs max is mu s into n. Don't worry, I'll explain you all the points. I'm just writing it down for you. This mu is basically called as the coefficient of static friction. This mu k is called as the coefficient of kinetic friction. What do I mean by this? Okay, all these things. See, imagine there is a box over here. It's on a rough surface like this. I am pushing it by some force. I will call that force as P. And because of that, there might be some friction which it encounters, and that friction is over here. Okay. This box wants to move right side, the friction acts this way. Let's see what exactly happens for different kinds of forces. Here friction, here our push, and here we'll talk about the motion. And let's repeat this process for different values. Say for example, I am applying a push of 0 Newton. Then I increase the force to 1 Newton, then maybe 1.5, then maybe 3 Newton, maybe 4 Newton, maybe 5, maybe 7, maybe 10, okay, maybe 12, okay, then maybe 14 Newton, maybe 20 Newton, like that. I'm increasing the push slowly, slowly I'm increasing that push. How will the friction react? Let's try to see. Let's say I observe that till I apply a force of 5 Newton, it doesn't move at all. I see the motion, it doesn't move for 3, it doesn't move for 4, it doesn't move for 5. After 5, it begins to move. And I see it is in motion. That's what I observe. This is the observation. Now, from this observation, what are you able to conclude? See, as long as it was not moving, basically all these cases were for static cases. And once it is in motion, it is the case of kinetic friction. It is the case of kinetic because it is in motion. This particular part, the first part tells, initially the friction will adjust itself so that the body remains at rest. If this is at rest, if no force is applied, friction will also not act. No reason for it to move. If the push is increased to 1 Newton, friction will also increase to 1 Newton. If you apply 1.5, friction will say I will also become 1.5. If you apply 3, this will also become 3. If you apply 4, it will also become 4. If you apply 5, this will also become 5. So can you see it is self-adjusting in nature? Can you see the frictional force is self-adjusting in nature? Yes, Ramadevi, I will be doing all the chapters. Yep, we'll be doing all the chapters. Don't worry. Don't worry. Can you see that, my dear students? Yes or no? Perfect. So you can see friction is self-adjusting in nature. After this is where it starts moving. So there is a limit till which it was able to keep it stationary. Hence, can I say this particular 5 is actually, our Fs max. This is the maximum friction which can be applied by static friction. All these values were just Fs. All these values that you see over here were lesser than Fs max. They were just in general static friction. This was the maximum static friction. Yep, phi is the limiting friction. Correct, Pratibha. After this, what you notice is, if you do the calculations, if you see how much acceleration force is, you will see one very interesting thing. This friction, instead of keeping itself at 5, it will now become, let's say, 4 Newton, and it maintains that 4 Newton. This is just some experimental random values I have chosen. Don't think, sir, kinetic friction told 4 Newton. Everywhere kinetic friction is 4 Newton. No, this is just an example. You can see the kinetic friction is not changing, it is constant. That's exactly what I told you over here. It's constant force, there is no limit, but static friction has a limit, it adjusts itself. Okay, here it was opposing relative motion, here it is opposing tendency. I will come to that also in a bit. But what you can see, the kinetic friction will remain constant. In these cases, in the initial cases, you can just say, when it is static, say 1 Newton is that way, another Newton is that other way. For example, 1 Newton is towards the right, or here 3 Newton is towards the right, minus 1 Newton, minus 3 Newton. What you get as a result is mass multiplied by acceleration. Acceleration is 0. But here, okay, this is going to happen till 5. After this, what happens is, if you do 7 minus, or let's say 20 minus the frictional force, which is 4 in this case, you will get this is equal to mass times the acceleration, is equal to mass times the acceleration. This acceleration will be there. Can you see the acceleration will be different here versus here? The acceleration will be different here versus here. Okay, kinetic friction remains, applied force might increase, so the difference of those two forces causes that acceleration. I hope this is very, very clear. All right, great. Now, if by chance somebody doubles that mass or increases that mass, okay, so earlier, let's say it was mg like this, there was normal. Somebody, instead of taking mass of m, they take a mass of 2m. So now this will be 2 mg and this normal will also increase. What you will notice is this table will change slightly over here. So maybe let's say 0, 2, 4, 5, 6, okay, 8, 9, 10, 11, 14, 15. I've just taken some random values. This will be 0, this will be 2, this will be 4. Basically, it will not move here, 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 even here. You might think it will move at 6 Newton because, you know, it started moving after 5 Newton, but that is wrong, guys. You will see it will not even move for 6, 8, 9 or even 10. Rather, it will start moving for 11, 14 and 15. Why is that so? Because you will see the limit has now been changed. It has now been increased. You will now see that the new limit, you will now see that the new limit for this, you will see the new limit for this is 10 Newton. So this will be 5, this will be 6, this will be 8, this will be 9, this is 10. This 10 is Fs max. This 10 is Fs max. So all this much is for static friction. This is when the friction goes into the kinetic mode. This is when the friction goes into the kinetic mode. After this, the friction will drop down. After this, the friction will drop down over here, and you might see maybe this might just become, let's say, 8 Newton. Maybe this might just become basically 8 Newton. This remains as 8 Newton. This remains as 8 Newton. So you will see that, kinetic friction will be constant. Okay, it is self-adjusting till here. This is the limit of the friction, and the limit has been changed because you have changed the normal. That is the reason why you see that Fs max is basically directly proportional to the normal force. If you increase the normal, Fs max increases. The constant of proportionality is called coefficient of friction. Same thing here, kinetic friction is proportional to the normal. If you increase the normal, frictional force will also increase. That constant is basically called as mu k. Mu k. Perfect. Now, if I assign these masses, some masses, let's say this is, I don't know, maybe 40 kg or something. This is 40 kg. So this is 40 g. Okay. And over here, this is 40 kg. I just put it over here. From these data points, because Fs max was 5 Newton, using this formula, Fs max is equal to mu s into n. Fs max was 5, mu s I don't know. Normal will be basically 40 into g. G is basically 10. So 5 goes with 10 2 times. So basically our mu s will become 1 divided by 80. So that is the value of the coefficient of static friction. That is the value of the coefficient of static friction from this problem. Is that clear, everyone? Similarly, if you want to find the value of the kinetic friction from here, use this value. Fk is nothing but mu k multiplied by n. Kinetic friction was constantly 4. Mu k I don't know. Normal is just going to be 40 g. G is nothing but 10. So guys, 4 and this 4 cancels. So mu k will be 1 by 100, which is basically 0.01. So that's how experimentally you can find the values. In the exam, it is given to you. Okay, or you can find it out if some values are given to you. Is it clear? It's not like the mu s and mu k value will change here. Here also mu s will be 1 by 80, mu k will be still 1 by 40 only, because the mass is doubled, normal will double. That's why everything has been doubled. So mu value won't change, it will still be the same. So from this, can I also conclude one more thing? And that is, see the values guys of mu s and mu k. Mu s is basically more, mu k is basically less. 1 by 100 is less than 1 by 80. So 100% I can say mu s is more than mu k, but usually the values are so close to each other. Mu s approximately is equal to mu k. Approximately we take the average value as mu. Usually in most of the problems we do not find so much of difference, so we say okay, it is same thing, like 0.689 versus 0.682. 0.689, 0.682, I can just take it as 0.68, forgetting the third decimal. Okay, I hope this is absolutely clear. PS, I'm not at all rushing, bacha. I'm not at all rushing. I'm taking it very slowly. If somebody is teaching you this slowly, you should really appreciate. Okay. Now, from this you can see one more thing, and that is Fs max. Fs max over here. Where does it go? Yes. Fs max over here is definitely higher than the kinetic friction. Fs max is definitely higher than the kinetic friction. So you will see that Fs max is always more than the value of Fk. The difference is not huge, but still it is going to be there. What it means is that, see, till you start the motion, it is difficult, but once the motion starts, the resistance automatically reduces. This is true in life also. Till you sit for studies, today you sat for studies, it is difficult. 1 Newton resistance is there. Tomorrow you try more resistance is there. Tomorrow, day after tomorrow you try even more resistance is there. Once you get that momentum, you start flowing, you start solving problems, you start practicing. Once you are in motion, you will see the resistance automatically reduces. Very true in real life, very true here also. As once the surfaces begin to slide, the surface does not have enough time to make contact. It does not have enough time to interlock itself with the bottom surface. So you will see once in motion, due to inertia, it becomes easier for it to move, rather the resistance reduces. Okay, rather the resistance reduces. Perfect. So that is why Fs max is more than Fk. It's easier to continue than to initiate motion. Last point over here, guys. Last point over here. Both of them, they have a common thing, and the common thing is both are independent of area. Both are independent of area. Just because contact area is more does not mean that the friction is more or less. It is found that the frictional forces do not depend on the area. And because of the manner in which I have shown you the table and the these values, so I can also plot a graph. I will just show you this graph. Very interesting graph. On the y-axis, I have friction, and on the x-axis, I have the push which I am applying, starting off from 0. You can very well see till a limit, the friction increases along with the push. Whatever is this value is the same value. So definitely, I can say that the graph is just a simple straight line till a certain value. But after that value, no matter what you do, friction drops and maintains that constant value. So hence, the graph should definitely take a drop and remain constant, something like this. This is what will happen. This particular value over here is definitely Fs max. This is Fs max, and this particular value over here is obviously Fk. So friction increases, drops and remains constant no matter how the push is. This is a graph of friction. Is it clear, my dear students? Understood this concept? I hope this is absolutely clear. Let's move to the next one. So to quickly summarize, static friction always acts when the surfaces are not moving relative to each other. Kinetic friction always acts when the surfaces move with respect to each other. Static friction adjusts itself to keep it at rest, but there is a limit till which it can tolerate, which is called Fs max. So the static friction has a range of values right from 0 till that limit, and that limit is given by μn. Once it enters into the kinetic zone, it remains constant as long as it is moving, and that value is mu into n, but that mu is called μk. Mus is always more than μk. That is what you should also see, and this graph tells you why it is also so. Okay, right. So let's solve some questions, guys, on this. Imagine Oh, there is one more thing. I forgot to explain this particular point, which is it opposes the tendency versus it opposes the relative motion. There is a difference between the two. See, imagine what is the meaning of tendency versus actual relative motion. Imagine you are right now sitting in the class, okay, and maybe you start thinking about some, I don't know, your friend. Oh, my friend, I have to meet him, I have to party with him, I have to watch a movie, we have to play games together, we have to just chill out, I want to sleep. So your tendency is to get distracted. Then you suddenly think, okay, wait, no, NEET, I have to clear it, I have to score marks, I have taken a drop, competition is high. You bring back yourself. Okay, you bring back yourself. Your tendency was to get distracted. That NEET motivation brought you back. Okay, so static friction opposes that tendency to move. It will not actually move, but it will be like, I am having a desire, I want to move. If you even think to move, friction will say, wait, I will not allow you to move. But if you are like, no, I don't want to move, friction will be like, okay, no problem, I will not apply on you. Just like it happened over here. When there was no tendency, friction was also not there. But the moment it tried even to move, there was a tendency to move, friction automatically opposed that tendency. But then when you talk about kinetic friction, it is actually opposing relative motion. Meaning you are getting distracted in your thoughts while watching this class. I want to meet my friend, okay, teacher is not looking, I will go out. You start walking out. Teacher catches you. Where are you going? Come back over here. Pulls your shirt and puts you back. So kinetic friction is exactly like that. When you actually start moving, that kinetic friction will be like, you are moving this way, I will oppose it. If you are going that way, I will oppose that direction. If you go this way, that kinetic friction will act the other way around. So kinetic friction opposes actual relative motion, whereas static friction opposes only the want, the desire to move, which is the tendency. Is that okay, everyone? Till this point clear? Sukanya, we just started, bacha, 1.5 hours back, 1 hour 50 minutes back. Okay, so don't worry. Now we are going to problems. Your mind will be occupied. See, that is the distraction, Sukanya. Hai na? Let's move to some questions on your screen. So there is a block over here. It is kept on a surface like this. Let's say the mass is, example, 20 kg, and let's say, for example, the coefficient of static friction and kinetic friction both are given over here. So the coefficient of static friction is 0.4, coefficient of kinetic friction is basically 0.3, and it is clearly mentioned that you are pulling it by applying some force, and that force happens to be, let's say, at an angle like this, making, say, 37 degrees, let's say, 37 degrees. All right. Now, imagine you have to find exactly the value of the force for which it begins to move. Find F for just moving it. Number two, find that force to produce an acceleration of, let's say, just 2 meters per second square. Find that force to produce an acceleration of just 2 meters per second square. So let's try to solve this particular question, guys. Let's take both the cases one by one. First is just moving. When I say just needs to move, that means what do you need to overcome? What do you need to just overcome? You will have to overcome the maximum limiting static frictional force. So when you show the forces acting on the body, You will say, wait sir, see that 20G force is acting downwards. Sir, that normal force is going to act upwards. Sir, this force which is there, I can split it up into two components, sir. Okay, fine. One force is like this, sir. So it is F cos 37. Cos 37 is nothing but cos 37. What is it, guys? Cos 37 is 4 by 5. So it will be basically 4F by 5. 4F divided by 5. And then there will be one more small component over here, which will be F sin 37. Sin 37 is 3 by 5. So it will become 3F divided by 5. You just want to move it. You are pulling it. So clearly there is a tendency in this direction. There is a tendency. It tends to move over here. So what will friction do? Friction will say, wait, I'm going to oppose you, and friction will act like this. Friction will act like this. This will be static. It is trying to keep it at rest. I have not yet begun the motion. I want to move it. Before that, it is at rest. So when I just am about to move it, this friction has reached its limiting value, which is Fs max. Is this free body diagram absolutely clear for everyone? Let me know. Give me a thumbs up, then we'll proceed. Did you understand this free body diagram? Okay, I've split the forces into two components. If you forgot the value of cos and sin 37, here is a quick reminder of that particular triangle which is there. If this is 4, this is 3, this is 5. Remember, this is basically your 37. This is basically your 37. This angle over here is 53 degrees. So cos 37 is 3 by 5, cos 37 is 4 by 5, sin 37 is 3 by 5. That's how you get it. Okay. Now I will write down the equations and see what do I get. In the y direction, I can see normal plus our force which is there 3F by 5 is equal to the weight which is basically 200G. All right. In the x direction, if you notice, this force will balance Fs max. So 4F by 5 is being balanced by our Fs max. But wait a minute, Fs max is mu s multiplied by n. Mu s is nothing but 0.5. Normal force is the one which we need to be careful. It is not 20G. It is not 20G. It is something else only, because there is a component of this force. When you pull it, normal will no longer be the weight, it will be something else. So it will be 20G minus 3F by 5. So substitute that over here. It is nothing but 20G minus 3F divided by 5. That is basically your 4F divided by 5. Now just rearrange the terms. Just have to rearrange the terms. So 4F divided by 5. This is minus 3F by 5 into 0.5. Goes on the other side. It will become 0.5 multiplied by 3F divided by 5. This will become plus because this was minus there. Is equal to 20 into 0.5. 20 into 0.5, and G value is basically 10. Now guys, simple things over here. Just see. 0.5 into 3 is basically 1.5. 0.5 into 20 is basically 10. 10 multiplied by 10 is basically 100. Okay. 4F minus 1.5 is basically 2.5. I hope you can see that. 4 minus 1.5 is nothing but 2.5. So 2.5 F divided by 5 is equal to 100. Perfect. So rearrange these terms and see what do you basically get. That's all. So F will be 100 multiplied by, oh by the way, 2.5 over here and 2.5 over here and 5 goes 2 times. So therefore, I can just write it over here only. Therefore, our F will become just 200 Newton. That's it. F will just become 200 Newton. So this is that bare minimum force which is needed for it to just begin to slide, which is needed to just begin to slide. Isn't it amazing that we have solved this question which involved a force at an angle? So that was the first part, for it to just move, for it to just basically move. Now, the next part is where you want it to accelerate by 2 meters per second square. Yep. Yes, Ramadevi, I have already answered you. I will be doing it. Acceleration wants to be 2 meters per second square. So let's redraw the diagram again. Again, there will be components of this force. This would be 4F by 5. You will have 3F by 5. You will obviously also have this normal. You will have 20g. And this time you also have an acceleration of 2 meters per second square. It is actually moving here, so friction will actually oppose it. Friction will actually oppose it, and it will be kinetic in nature. Why is it kinetic? Because it is moving. Because it is moving. Keep that in mind. Correct? Okay. So let's write down the equations again and see what do you get. Again, in the y direction, you will get the same equation. Normal plus 3f by 5 is equal to 20g downwards. So I can just say normal is equal to 200 minus 3f by 5. That is your y direction. In your x direction, this minus this is mass into acceleration. So 4f by 5 minus kinetic friction is mass. Mass is 20 multiplied by acceleration. So therefore, it will be 4f by 5. Kinetic friction is mu k into n. Mu k is basically I'm so sorry guys, I think in the last problem I used mu s as 0.5 instead of 0.4. So let me do one thing, let me change the values here only because I have already solved the problem. So let's do this, so sorry. I think I used some wrong values. So this was 0.5, this was 0.4. I'm just changing it because now we cannot change the entire problem. So just changing the question. Okay. So this will be nothing but 0.4 into the normal force, which is this value, which is nothing but 200 minus 3f by 5, which is our normal force, and this was our mu k value, is equal to mass into acceleration, which is basically 40. Okay, let's find this out now. What will happen? This minus and this minus will become plus. So 4f divided by 5, minus and minus becomes plus. It will become 0.4 multiplied by 3 divided by 5 times of f. This will become minus 4 2s are 8. So this will be 800, but shift the decimal, so it will just become minus 80 is equal to 40. 0.4 into 200 is just going to be 80, guys. Take that 80 on the other side and play with this now. What will happen over here is this into this, 4 3s are 12, so this will be 1.2. Now 4 minus 1.2. 4 minus 1.2 is basically 2.8. So this will be 2.8 times of f divided by 5. 2.8 divided by 5 times of f will be 80 plus 40, which is nothing but 120. Which is nothing but 120. So rearrange this further. I will get f is equal to 5 multiplied by 120 divided by 2.8. So this will be nothing but 600 divided by 2.8. You can calculate this value. Okay, I'm just going to use the calculator to find it, but you can obviously do it using your normal division also. So this value comes out to be 600 divided by 2.8, which is 214 Newton approximately. 214 Newton approximately. That is the answer. Cool. So you can see this value is slightly different from the previous value. To just begin the motion, we needed 200 Newton. To keep it accelerated by something, you needed some more Newtons of force. That's what this problem says. Amazing, guys. Shall we move to the next question on your screen? Okay. Now, this is a concept where you have inclined plane, like this. Okay, look at all these cases. Slowly I'm increasing the inclination. I'm pretty sure you would have done this also at your school level, where you probably hold something on an inclined plane and slowly increase the angle, and then it begins to move. It begins to slide. So till a point, it is able to maintain that body as it is over there. But after a point, it is not able to maintain. It begins to slide. So maybe over here, it is at rest. Maybe over here also it is at rest. Here also maybe it is at rest. But on the verge of sliding, there is a difference in this and this. Here it does not feel like it is going to slide, but here it feels like you just tap it a little bit, zip, it will slide. Here it is actually sliding. So what will happen in all these cases is that here static friction will act like this. This case, this friction will be the maximum. It will be Fs max. And once you go over here, because it begins to slide, it will be kinetic friction. Reason for that, in this case, the tendency is over here. Tendency to move is over here. Tendency is maximum. You cannot expect the friction to increase beyond this. That's it. This is the maximum limit. Here it actually slides. So there is actual motion. That's why the friction goes into kinetic. So this angle which is there over here, where till which you can maintain the body, is called as the angle of repose. It is called as the angle of repose. Usually the symbol is alpha. As long as theta is less than or equal to alpha, it will not slide. But the moment the angle of inclination is more than the angle of repose, it will slide. That is the concept of angle of repose. Is this clear, everyone? Okay. So how much is this angle of repose? We want to find it out. So let's draw a diagram, simple one. When this particular box is at that critical angle, right over here, that critical angle being alpha, this is our mass m. What forces will be there? Let's try to figure it out. And remember, whenever I have such diagram, it's best practice to probably divide this into 8 parts, probably something like this, so that it makes the problem easy for you. So we know for sure that this angle is theta, even this angle is theta, even this angle is theta, even this angle is theta. Division of 8 parts, actually instead of theta it should be alpha. This is alpha, this is also alpha, this is also alpha, this is also alpha. This is alpha, so this is alpha. Leave one, go to the next, leave one, go to the next, leave one, go to the next. Every alternate angle will be alpha. That is the trick which I have taught you. Now show the forces, guys. Obviously mg will act like this, but I will split this mg force into 2 components. One component like this, because it is closer to alpha, I will call it mg cos alpha. The other component will be like this. This will be mg sine of alpha because it is far away. Obviously, there will be a normal reaction like this. So, I will show normal, and the friction will act like this, and that will be your Fs max. And still the object is at rest on verge of sliding, on the verge of sliding at the angle of repose. On the verge of sliding, just like this particular case, which is angle of repose. So in this direction, can you see the normal force is mg cos alpha? In this direction, can you see mg sine alpha is Fs max? But what is Fs max? Mu s into n. It is static friction multiplied by the normal. Do I know the normal? Yes, I just figured it out here. So it was mg cos alpha. But on the left hand side, I have mg sine alpha. So basically mg will cancel. So sine alpha will remain, mu s will remain. Bring this cos alpha downstairs. mg has cancelled. So what is sine by cos? It is nothing but tan alpha. So tan alpha is basically mu s. So alpha is basically tan inverse of mu s. That is the answer. Alpha is basically tan inverse of mu s. Is this understood, everyone? Now this becomes a very crucial formula. Crucial formula. Tan alpha is equal to mu s. Just to give you a simple example, imagine if somebody says, listen, the coefficient of static friction is, let's say for example, we take some value like 3/5, okay, 3/5, all right. Then what will be the angle of repose for such a surface? We know tan alpha is equal to mu s, so that means not 3/5, sorry, let's take it as 0.75. Tan alpha is equal to mu s, which is basically 0.75. 0.75 means 3/4. Whose tan is 3/4? It is basically 37 degrees, which means just exactly till you reach 37 degrees, you are safe. This angle is okay. Even this angle is okay. All these angles, there is going to be no sliding. But the moment you increase the angle beyond this, there will be sliding. There will be sliding. That is the meaning of it. Yes, Sukanya, you will be getting the notes. I hope you know where you get the notes. In this description box only. First of all, you can join the channel, which is the Telegram channel, the WhatsApp channel. There we send the notes. Apart from that, do you see the complete NEET preparation treasure box? It's absolutely free. Okay, so just go over there, open it up. I think I'm not yet logged in, or yeah, I'm logged in, thank God. So you can see all the lectures, their links, notes. If there is a previous year question bank, chapter wise PYQ PDF, NCERT solutions, everything has been maintained over here. Same thing with physics also, math, biology also, and chemistry also. Whether it is class 11th or 12th, everything has been maintained over here. Is that okay? Cool. So use this. Perfect. Let's do another question, guys, on your screen now. Okay. Let's say there is an inclined plane. There is a pulley like so. There is a surface over here. There is a mass over here. Let's say the mass is m. The coefficient of static friction is, let's say, 0.2. This surface has an inclination, let's say, of 53 degree. This rope is then connected to another mass, of 2m, and the system is left. Question is to find the acceleration of the box. Find the acceleration of the blocks. That is the question. Let's try to do this. Look at the diagram. There is friction over here, maybe even over here. Actually, the entire surface is rough. Let's assume that. And we have to solve the problem. Let's try this. Okay. Welcome Shreya. Welcome Tanuja. Welcome Sukanya. Now, when the surfaces were smooth, it was very simple. You draw the free body diagram. Very simply, you get the answers. Here also, there is only one extra step, that you have to show the frictional force. That's the only catch. Rest procedure remains the same. So let's try to do it. Let's show the forces on both the bodies. Only then we'll be able to solve the problem. Let's start by doing it for probably this mass over here. Let's show this particular mass over here. So what are the forces on this particular mass? One is its own weight, which is mg. There will be a normal reaction, let's say I call it N1. There will be a string which will be pulling it, so tension T. And because of all of this, it will end up accelerating like this way. So the friction will not like it, it will oppose the motion. So friction will act in this direction. And this friction will be kinetic in nature. This will have a value of mu into n. Mu k into n. Mu k is basically 0.2. Normal force is mg. So 0.2 mg, which is also mg by 5. So mg by 5 force will be the frictional force opposing it in this situation. If I write the equation, it will look something like this. Tension in the direction of acceleration minus the kinetic friction will be equal to mass times of acceleration. So tension minus mg divided by 5 is equal to ma. That is the equation. That is the equation. Okay, let's keep it aside. Now, let us draw the free body diagram of the 2m mass. Let us draw the free body diagram of the 2m mass and see what are the different forces on it. I know mg will act down, but I will not show it down. I will already split it into two components. And we know this is usually the cos, this is the sine. Let's use that same thing. So this will be 2 mg cos, what is it? 53. Cos 53, guys. What is the value of cos 53? What is the value of cos 53? It will be 4 by 5. Sorry, 3 by 5, my bad. 3 by 5. So it will be equal to 2 mg multiplied by 3 by 5, which means it is 6 by 5 times of mg. 6 by 5 times of mg. Cos 53 is 3 by 5. Similarly, this force will be 2 mg sine 53. Sine of 53, just check it out. Sine of 53, guys, it will be nothing but 4 by 5. 4 by 5, 2 4s are 8. 2 4s are 8, so it will become 8 mg divided by 5. 8 mg divided by 5. Then there will be a normal force like this. So I will show it N2. Friction will not like it, it will oppose it. This friction again mu into n. Mu is basically 0.2. But normal, how much will be the normal in this case? This normal will be exactly this. So it will be 6 by 5 mg. 6 by 5 mg. 0.2 into 6 is basically, you can think of this as 1 by 5. So 1 by 5 into 6 by 5 mg. So it will be 6 by 25 times of mg. And as a result of all of this, it is also accelerating downwards. And let's not also forget, there is one tension also over here. There is also one tension over here. These are the only forces, just check this out. Yep. Very good. Awesome. Now let's write the equation. In the direction of acceleration, this force is there. So I can say 8 mg by 5 minus P minus kinetic friction, which is 6 by 25 mg, is equal to mass, which is 2m, into the acceleration. Now pay close attention to this equation number 1 and this equation number 2. you can very easily see here you have plus t, here you have minus t. It's obviously making sense that we add these two equations so that what happens is this tension and this tension just cancel out with each other. So what I will be left out with is this 8 mg divided by 5 minus 6 by 25 mg. Even this minus mg by 5 will come, minus mg by 5 will come, is equal to 2 ma plus over here ma. Maybe I'll go to the next slide. Maybe I will have less trouble. Or let me just simplify over here only, how much ever I can. So LCM is basically 25. LCM is basically 25. So let's make it 25. So I'll have to multiply it by 5. So it will become 40. So it will now become basically 40 minus 6, and even this over here. Take the LCM, guys. Oops. Take the LCM. Make this 25. So I'll have to put 5 over here. Perfect. So what do I get? 40 minus 6 minus 5. 6 and 5 together will make it 11. So 40 minus 11 is nothing but 29. So this will become 29 mg by 25 is equal to 2 plus 1 is 3. So 3 ma. Obviously over here this mass and this mass cancels. So I think in the next step I will get the answer over here. I'll just do it over here. So acceleration will be 29 by 25 into g, and that 3 comes over here. So it will become 29g divided by 25. 3 is a 75. So that's the value of the acceleration. That's the value of the acceleration. Where can we find the schedule for the live class? Subiksha, the schedule is available directly on our channel only. Just go over here for the complete week. On Sunday or Saturday only we schedule all the classes over here. You can see upcoming classes. You can also say notify me. So you'll also get a notification on your tablet or phone or laptop. Okay. So all the classes live, you will see it in upcoming. So we schedule the classes 1 week in advance only. All right. Already we are on Wednesday. So most of the classes for this week, half of them are done. Clear? Understood how to solve these block questions? So guys, we have done quite a few questions on friction now. Okay, right over here. Let's take one more question over here. Let's take one more question now. Now this time it will have block over a block and then you have to solve it. There will be blocks over the different blocks and then we'll have to solve it. See, just to give you a simple scenario, imagine there is a box over here and another box over here. Just say on the upper box, the friction is example 2 Newton. Do you think the lower box's upper surface will also encounter friction? I will repeat what I am trying to say over here. See that upper part which is there versus this lower part. I said that upper part experienced a frictional force of 2 Newton. Do you think the lower part of, the lower block's upper surface, which is this, will also encounter friction? The answer is yes, it will, because by Newton's third law, action and reaction, so this would be 2 Newton. This would be 2 Newton. If this I call it as action, obviously this will be the reaction. It acts on the different body. So whenever you have block on block problems, remember Newton's third law is very important. One action and reaction will always come between the surfaces. Similarly, over here, if I tell you, listen, on the upper block, there is a frictional force of maybe 5 Newton over here. 100% on the lower block, there will be a frictional force of 5 Newton. If at all it happens that there is 0 Newton friction on the upper block's lower surface, this part which is the upper surface of the lower block, will also encounter 0 Newton friction. Newton's third law. Newton's third law at the end of the day. Now, imagine these surfaces begin to move. So, say this is that block, this is that another block. So these are block over block problems. Let's say this block is moving at a speed of 15 meters per second. This block is only moving at 10 meters per second. Here, this is moving at 7 meters per second. This is moving at 10 meters per second, like this. Here, this is maybe moving over here at 5 meters per second. And maybe this is moving like this at, let's say, 7 meters per second. Some random scenarios I have chosen. I have shown you the speeds. Can we figure out what might be the direction of friction in each case? I think so. Observe this. If from the lower block's perspective, if you look at the upper block, I think there is a relative motion in all the cases because their speeds are not equal. I feel there is a relative motion. And whenever there is relative motion, what did I tell you? Kinetic friction will act. Okay. So can you tell me, with respect to this lower block, what is the relative speed between them? I have told you this concept in relative motion. If the direction is same, your hands come down together, it looks like a minus sign. So speeds will subtract. So 15 is faster than 10. So 15 minus 10 is just 5. So 5 meters per second relative motion. Similarly, look over here. With respect to that lower surface, I think that upper surface is moving. Same direction. Bring the hands together, looks like a minus sign. Relative speed will be 10 minus 7, but this is slower, this is faster. So it will appear to go slower behind, in fact, with a speed of 3 meters per second relatively. This is a relative motion. Here, with respect to the lower surface, if you concentrate on the upper block, both are going in the opposite. Opposite symbol is this. Turn the opposite symbol, looks like a plus. So add the speeds 5 and 7. So 100%, the speed will be 12 meters per second, again relatively. This block will appear to go behind with respect to the lower surface. Is this concept clear? Now it looks like a simple problem to me, because if this block moves right way with respect to the lower surface, so the friction on it will be definitely here. If this block goes left side, 100% the friction will be here. If this block goes this way, 100% the friction will be here. Whereas for the lower surface, obviously action reaction, what did I tell you? If one force is this way, other force will be the other way on the other body. So on the lower surface, the friction will be here. On the lower surface, the friction will be here. On the lower block, the friction will be over here. Is that clearly understood? Everybody with me? Everybody with me? Yep. So if at all you have to draw the free body diagram of this block, you will show the friction left side. If you draw the free body diagram of the lower block, you will show the friction this way. But at the same time, do not forget, these blocks are moving on the ground. These blocks are moving on the ground. So there is a friction between these two surfaces also. Friction between these two surfaces also. That friction is very simple. This block is moving right, so the friction will be towards the left. This is kinetic friction by the ground. This block is again moving towards the right, so kinetic friction will be towards the left. Kinetic friction will be again towards the left by the ground on the block. Okay, so that's how you show the forces at different surfaces. You can see Newton's third law at play here, relative motion concept at play here. You don't need these values. Even if you know the direction, it's okay. It's fine. No need to find out the values. Okay, so let's do a question based out of it. Okay, you have a block like this and another block like this, and they both are on a surface like this. Let's say this is 3m, this is m, and you are going to apply a force over here, and that force is what we need to find out. If this is going to be mu, the question is find F such that both of them move together, they are going to move together, and you have to find the maximum value of F. Why maximum? Why not anything else? If I pull the lower block, because of inertia, this mass will tend to go behind. Because of inertia, this mass will try to fall back. If I pull it very forcefully, this inertia will try to resist it, and it will try to slide even more. So the tendency to slide increases the moment you increase the force, and the lower block begins to slide at a much faster rate. So because of which, there are higher chances of slipping when this force is more. Make sense? Very good. This is the last, I think last 1 or 2 problems. After this we are done. So yeah, the lecture will stop. So don't worry. So I apply a large force, this mass will fall back behind. So there is a limit till which I can increase the force, and that's exactly what we need to find. So let's do that. Guys. So in the limiting case, what will happen is, in the limiting case, if I draw the forces on both the blocks, obviously there is mg over here, there is one normal force over here. This normal is being applied by 3m on m, so the reaction of it will be on this block. So the same normal will act. Okay, this will be 3mg, guys, and from the ground there will be another normal. I will call it n2. This external force was anyways there. The bottom surface over here was anyways given to be completely smooth, so don't worry about it. Okay, so now what do we do next? Let's see the directions of the friction. Before that, because I'm pulling this entire system, there is complete smooth surface over here. Both these blocks will move together. Because they are moving together, that means there will be some kind of acceleration. So there will be some kind of acceleration here. Now figuring the direction of the friction is an easy task. Think now, if this upper block of mass m is accelerating right, normal and mg can't accelerate it. Who else will accelerate it? There is only one force remaining, which I have not yet shown. Who is it? Friction. So 100% the frictional force will act over here like this on that particular surface. Is that right? Frictional force will act towards the right side, because that's the only way it can accelerate, no other way. So in fact, I will write also F is equal to ma. There is no other way I can solve this problem, right? And this frictional force will be limiting value. So it is not any normal friction, guys. This friction will be the limiting value. So F max, I can say, is nothing but m into a. F max is mu into basically n, mu into n. But what is the value of n? N is nothing but mg. So mu mg is basically ma. Mm cancels, so a will be basically mu times of g. That is what I get from the first block on the top. Acceleration is mu times of g after cancelling m. If you look over here, there is one force missing, which is the friction. Don't forget it. If if F max acts right, obviously on the upper surface it will act towards the left. It will act towards the left, action reaction. Correct? So now if you write the equation, it will look like this: F minus F max, this minus this is mass into acceleration. Mass is 3m, into acceleration. What is that F max? We have already found it out. It is already found it out. We have already found it out. It is nothing but equal to ma. So just put ma over here. Just put 3 ma over here. Perfect. Okay. Acceleration was, we'll put that later on. All right. So ma shifted over here. It will become 4 ma. But wait a minute. Acceleration was mu into g. So just put it over here. So therefore, I can say that the maximum force is 4 mu mg. That is the answer. The maximum force is 4 mu mg. Yep. Yes, Krishna. Dipanshu from NIT Nagpur. I did my BTech and I did my research from IIT Bombay. Right? Okay. So even if you see my introduction slides in most of the classes, I think you would have seen it over there. Anyways. So this is how basically you solve these block on block questions or figure out the direction of the friction in the block and block problems, guys. Okay, so we have done this also. Multiple block problems also we have done over the pulleys and also angle of repose, of course. So these were some concepts about friction which we have done today. We have done pseudo force. We have also done multiple pulley problems. We have done the nature of friction, their classification, everything. Before that, the first lecture, we have done all forces and how to solve pulley, spring, tension problems. Now, this is not the end story of Newton's laws. Obviously, there will be more problem solving, but you will have to wait for it. But at least you have a head start now. At least you have somewhere to begin with. At least you have something to look up to, see how questions are done, see the concepts, understand it, and start applying it. I'm not saying solve all the PYQs right away. At least do the basic questions. At least do the simple questions. At least start something. Don't say, I will not do anything because one problem is tough. Maybe a problem very much later on might be very, very difficult or lengthy. Don't get disheartened by it. So push yourself slowly, step by step. There will be more problem solving sessions, but right now we are in full swing, full mood, full josh to, cover as much syllabus with as many concepts as possible in detail, right from zero, basics covered, all the foundation covered, building the concepts and getting you to apply those concepts into the problems. That is the purpose of these lectures. So make sure you do not miss any of these lectures and you also share these videos with your friends by subscribing, sharing, talking about the Vedantu NEET English channel. Liking this video also helps us, because of which YouTube recommends these channels and videos to all the students who are always looking for beautiful content, amazing content in English. All right. So make sure you're recommending, talking about it. That would be my biggest Teachers Day gift, right? Thank you guys so much for liking, sharing and commenting, and see you in the next class. We'll be doing circular motion after this. Okay. Bye-bye. Take care. Have a great time.